we want to find the value of this function, f of x, over the region A, where A is x and y, an element of r squared. So r squared just means that you have x and y, and x is an element of the real numbers, and y is an element of the real numbers. And we know that x squared plus y squared is less than or equal to 1. So that's going to be a circle with the area filled in. And then we also have the condition that y is greater than or equal to y equals absolute value of x. So y equals x is that line. And when we do the absolute value, we pick up this line over here. So this is going to be the region of y greater than or equal to absolute value of x. And specifically, the question would be, or what I would be curious about is is it this region or is it that region? Well, if you look up here, this is where the value of y is going to be greater than x. So it's going to be, so the region that we're concerned with is going to be that. Kind of like a little slice of pizza or pie. So we're going to have something kind of like that as a region we're integrating over. So what we want to solve is, we'll do double integral because it's an area, f of x, y, dA, where dA is just a derivative over area segments. Now we can look at area in different ways. We can do dx, dy, which is going to make little squares. But in this case, it'd be easier to do polar coordinates, which will be little, I guess, sections kind of like this, where we have a radius. This will be delta r, and it'll be over some delta theta. So I'm going to write in f of x, y real quick. So we know f of x, y is x squared plus y squared. And the dA, when you convert it, when you look at it in terms of polar coordinates, is going to be r dr d theta. This is r dr d theta right there. So basically you pick up an r and then you have the have the derivative dr and d theta. So now we want to convert x squared plus y squared into r squared. So x squared plus y squared equals r squared. You can kind of see this if you draw a triangle. You have x here, you have y here. This would be the radius, and Pythagorean theorem, that's going to be this is going to be r. And so you're going to have this relation here. X squared plus y squared is going to be r squared. So we can rewrite this one more time, and we have r squared, r dr d theta. I guess we're going to combine these to make this r cubed. So I guess we will probably write it one more time. Now we want to do the limits of integration. So we're going to go from r. So r is going to start at 0. It's going to go to 1 because we know that x squared plus y squared, which is the same as r squared, is less than or equal to 1. So that less than or equal to part means we're going to start at 0 and go up to 1. In this case, we're going to assume that r squared cannot be less than 0. And we're going to assume that because x squared is positive and y squared is positive. And traditionally, you don't assume negative radii. So r will be from 0 to 1. Now we want to find the angle, the theta, that we're going to do. So this is y equals x. So it's going to be pi over 4. Up here will be 2 pi over 4, which is pi over 2. And add another pi over 4, we're going to have 3 pi over 4. So we're going to integrate from pi over 4 to 3 pi over 4. So this will be pi over 4 to 3 pi over 4. And you could do this in degrees, but it's much easier to do this in radians. Okay, so I'm going to rewrite this one more time and then calculus it out. So pi over 4, 3 pi over 4, r cubed dr d theta. Okay, so we're going to use the power rule to take the integral of r cubed, which is going to give us r to the 4th. Not enough contrast with that. That's okay. From 0 to 1, d theta. And then I'm just going to leave those go down there. Boop. I know, it probably would have been easier just to write them in. We all make mistakes in life. When we do plug in 1 here and 0, we're just going to, the 1 is going to stay and the 0 is going to go away. And so we're going to be left with integral from pi over 4 to 3 pi over 4 1/4 d theta, which is 1/4 theta from pi over 4 3 pi over 4, which is 1/4 times quantity 3 pi over 4 minus pi over 4. 3 pi over 4 minus pi over 4 is going to be 2 pi over 4. And we'll still multiply that by 1/4. And 2 and the 4 will cancel to put a 2 in the bottom. And so we have an answer of pi over 8. So when you have the question, what is the value of this function over this region, you get this integral. And solving this integral, it's easiest to look at in terms of polar. So you look at the derivative of the area, dA, it's r d theta. And you convert x squared plus y squared into r squared. You get r cubed because you pick up an r from the dA. And then you integrate it using the power rule. Plug in some numbers and you get pi over 8 as the value. So I hope this helped. I will see you next time.